All right, welcome back. This is our part 2 of our properties of exponents. We're going to go through our rules that we have when we're talking about our exponents here. So again, write this down in your notebook if you have it, spiral notebook, folder, something to reference back to, because these exponents we will see throughout the year. The first one is the product rule. So product means multiplication. So as you see in each of the examples here, we're multiplying terms together. In the product rule, the bases are the same. The bases are going to be our variables that are the exact same. They are both x. So the product rule, you keep the base x and we add the exponents together. So it's going to be the base x raised to the a plus b is our product rule. So our first example here, they both have the same base of h. So I'm going to put h. And again, we are going to add the exponents. 2 plus 6. Well, we can simplify this. I'm going to keep my base h, and then we're going to add 2 plus 6. So our answer is going to be h to the 8th power. All right, 2 looks fun. So again, we are multiplying here. The very first thing you have to do is multiply your coefficients together. So negative 2 times 7 is going to give you a negative 14. Those are not part of our variables, so we just multiply those together. Both of these terms have a base of a. So I'm going to put a here, and then we are going to add the exponents together, which is 2 plus 3. Also, they both have a base of b, so I'm going to put b down here. If there's not an exponent there, do you guys remember what the exponent is? It's an exponent of 1, if there's nothing there. So when you bring your base b, really we're adding our exponents together, which will be our 1 plus 1. Simplifying our exponents here, bring down that negative 14. A, 2 plus 3 is going to be 5. Bring down our b, and 1 plus 1 is going to be 2. So again, this is our product rule here. The bases are the same. You're going to add the exponents. That's product rule. Then you have power rule. Power rule is slightly different than product rule, because if you see here, there's only one variable, or one base. So we're not going to be adding the exponents together. We're going to keep the base, and we are going to multiply the exponents. So base is x, your exponents are a times b. Let's look at example 1. Again, the base is x. I know it's the base because it's on the bottom. So x, and we are going to multiply our exponents together, which is 2 times 3. Well, what is 2 times 3? X to the 6th power is our answer. Okay, this one looks fun. So we have the first one, negative 2m to the 5th power, all of that raised to the 2nd power, times m to the 3rd. Let's focus on this one first. Everything inside here has to be raised to the 2nd power, including that negative 2. So negative 2 to the 2nd power is going to be a positive 4, because a negative 2 times negative 2 is a positive 4. Again, we have our base of m, and we're going to multiply that 5 and the 2 together. So 5 times 2. Again, I can drop the parentheses because I've already done everything with that 2 on the outside. And then bring down that times m to the 3rd. Let's continue simplifying this one. 5 times 2 is going to give us 10. So really this is 4 m to the 10th times m to the 3rd. But wait a second here. This now looks like 2 on the other side. We have the same base of m. So what am I going to do with the 10 and the 3? Well, we're going to add these together. So I have that 4 out front. I keep one of my bases of m, and I'm going to add 10 plus 3. Again, same base, add, one base, multiply. So our final answer is 4m raised to the 13th power. Good. Okay, quotient rule. Quotient means we are going to be dividing here. When we are dividing and they have the same base like they do with their x's, we are going to subtract the exponent with the top exponent minus the bottom always. So keep the base. Our top exponent is a, which we are going to subtract the bottom exponent of b. All right, at number 1, I've got 27 and 42 as our coefficients, or the numbers in front of our variables. Simplifying that, 3 goes into both of those numbers. 3 goes into 27 9 times, and into 42 14 times. So that's where we'll start. Again, when we have our quotient rule, I want to keep my variable in the numerator. So I'm going to bring that x next to the 9, and then we subtract our exponents together. Remember, if there's not an exponent, it's a 1. So our numerator exponents are now going to be 5 minus 1. So if we simplify this, this is going to be 9x to the 4th, all divided by 14 is our answer. All right, number 2. Ooh, before I can do my quotient rule, I've got to do my power rule, which was this one up here. One base, so we multiply our variables together. So my numerator is going to be y to the 2 times 2 over y to the 4th. Again, multiply our exponents. 2 times 2 is going to give us 4, so y to the 4th over y to the 4th. Quotient rule, I'm going to bring this number up to the top here. That's going to be y to the 4 minus 4. Again, 4 minus 4 is where I got that from, which will be y to the 0 power. And just like our last video, anything raised to the 0 power, our answer is going to be 1. That leads us straight into our 0 property rule. Anything raised to the 0 power, our answer is 1. Anything raised to the 0 power, our answer is 1. But there's that 7 there. So really, that's going to be 7 times x to the 0 power, or 1. So we substitute that 1 in. And what is 7 times 1? 7's our answer there. All right, let's continue on. I've got one base, 2 exponents, so I know I'm doing the power rule, which is that one there. Keep the base of w, multiply your exponents, 4 times 2, divided by our denominator of w to the 8th power. Simplify that numerator. That's going to be w to the 8th divided by w to the 8th power. We've got a division, so now I'm going to do the quotient rule by bringing this exponent up to the top. So keep our base w. 8 minus 8 is where I'm getting this from. And then 8 minus 8 I know is 0, so really this is w to the 0 power. And anything raised to the 0 power, our answer is 1. Okay, we got one more. Our negative exponent rule. Whenever you have a negative exponent, that's going to drop everything it's attached to, so in this case the x, to the denominator. So we're going to put a 1 in our numerator over x to the a power. So when it drops down to the denominator, your exponent now becomes positive. All right, that negative 2 here is attached to the x. I'm going to keep that negative 5 in the numerator. Not touching that, but I'm going to bring that x, the negative 2, down to the denominator, but I'm making that 2 now positive. That's our answer for that one. All right, last example here. 4 and 8. Let's go ahead and simplify that first. What number divides into 4 and 8? 4 does. 4 divides into 4 one time and into 8 two times. I've got a quotient rule here. I know it's a quotient rule because we've got our division sign. So I'm going to bring my exponent of 5 up to the top by subtracting it. So keep that k at the top, and we're going to have 2 minus 5. Again, you have to do your top minus the bottom. So let's keep going. I've got 1 over 2. My numerator is going to be k. 2 minus 5 is a negative 3. Well, we can't have a negative exponent, so we've got to take that k to the negative third and drop it down. So keep that 1 in the numerator, keep that 2 in the denominator, but we're now going to make this k to the positive third exponent.